All right, I'm going to go through the working on this question right here. This comes from ACE Physics Syllabus Code 9702, paper 13 from May, June 2015. It's question number 13, and it reads, a wooden block is freely supported on brackets at a height of 4.0 meters above the ground, as shown. It says a bullet of mass 5 grams is shot vertically upwards into the wooden block of mass 95 grams. It embeds itself in the block. The impact causes the block to rise above its supporting brackets. The bullet hits the block with a velocity of 200 meters per second. How far above the ground will the block be at the maximum height of its path? So here, we're going to, one thing to sort of keep in mind, I think right away, is that we're already 4 meters above the ground, and it's asking us for the height above the ground. And so whatever we calculate for what's going to happen to this block, we're going to need to remember to add these 4 meters back into it. And if you look at your answer choices, you can kind of see like 5.1, 9.1, 5.6, 9.6. Note that these answer choices are 4 meters sort of different from each other. So it's very likely that one of these is the correct answer for the displacement of this block. And students that are only mindful of that will choose whichever one it is, I'm not sure, and get it wrong, right? Because the last thing you have to do once you know how far above these brackets this block is going to rise, you have to add it to 4 and either get 9. So I imagine you could eliminate these 2 choices as incorrect right off the bat, because these would be designed to capture those students that forget to add the 4 meters back into it, okay? So it's got to be either C or D, but let's figure out which one of those it is. I'll begin here by determining the momentum of the bullet. And so it's mass times velocity. And I don't think it matters for this one because we're going to eventually solve for meters here. So like, do we need to convert grams to kilograms? It's just good practice, and so I'm going to do that. So 5 grams is 0.005 kilograms, and it's traveling at 200 meters per second. And so that's the way we would calculate the momentum of this bullet in the preferred units, kilogram meters per second. So 0.005 times 200 gives us 1 kilogram meter per second of momentum initially. The block is going to embed itself in the block. Sorry, the bullet is going to embed itself in the block, which means it's an inelastic collision, all right? So the momentum initially, which is this, right? All the momentum comes from the bullet because this is stationary, has to be equal to the final momentum sort of after impact, okay? So let's calculate what that should be. The final momentum is now the mass of the bullet plus the mass of the block, also starts with B. Wooden block, there we go, times some velocity over here, which is something that we'll be able to deduce from the rest of the known information. Remember that momentum is conserved and there's no sort of exception or violation to that. So this momentum is the final momentum. 1 equals, now we have 0.005 mass of the bullet plus 0.095, so that's 100 grams or 0.1 kilograms, right? 100 grams is 0.1 kilos. And then that's moving, let's be consistent and call that velocity V prime. All right, so we divide each side by 0.1, 1 divided by 1/10 is 10. So the speed of this bullet block system is 10 meters per second. Hey, that agrees with our claim for our lab work. Well, for the initial velocity of our dart anyway. So this would be the shared velocity of the bullet and the block, right? They're one new object now. That plus sign comes from the word embeds. So now that we know this thing is moving 10 meters per second, we could maybe say, let's use an energy argument. Let's say that the kinetic energy here is going to be turned into potential energy due to gravity. And so we could work out the 1/2 mv squared and set it equal to the mgh, and then solve for h. So get rid of mass, and h would equal 1/2 v squared right? And then we got to divide each side by g. So this is one way to get to the height. The other way would be kinematically. You know, you could solve what is the displacement going to be for something under the influence of gravity that has this initial velocity. And so you could solve it maybe using S equals 1/2 the initial velocity u plus the final velocity is 0, right? At maximum height, gravity has slowed it down to a stop. We don't know the time. We don't know the time. So we'd have to use v squared equals u squared plus 2as. And we use 0, 10 squared plus 2, 9.8, and we could solve for it this way. Which actually I think is identical to this, right? V squared, the acceleration is that due to gravity. So yeah, I think when you solve it with this equation of motion, it is mathematically identical to like what we get from energy. That's kind of neat, kind of nice. Right, because we divide each side by 2, there's the 1/2, yeah. See, let's just kind of see that. Solve this for S real quick. And you would say S would be, now remember, it's going to reach a final speed of 0, so v squared would be 0. So we subtract u squared from both sides. And then we divide by 2g. So yeah, it is exactly the same. You know, the 1/2 is the same thing as the 2 in the denominator here. So we'll have h equals half of 100. V is 10, so, or v prime, you know, is 10, so 10 squared is 100 over 9.81. Half of 100 is 50. 50 divided by 9.81 is 5.09, which is about 5.1. And how many students now would go and pick A? Nobody. Good, right? Because when we first size up the question, it's good to remind yourself of those little kind of tricks, because this is the hard part, right? The easy part is going, oh, it rises another 5.1 meters above where it is. The question asks me, though, what is the maximum height above the ground? And I'm already 4 meters above the ground to begin with. What does this solve for? It solves for the additional height above and beyond the 4 meters it already is. So don't be so satisfied with your answer here that you incorrectly choose choice A, when the last thing you needed to do is just go, oh, plus 4 equals 9.1. Well done for the e-learning student that offered this as the answer. And I think there were several in-person students as well that calculated C, or had a lucky guess who just guessed C. Good. Sometimes a lucky guess is all we need, you know. But you know, you should know the physics too. Y'all got it, right? It's the same, right? It's the same physics, right? That's kind of the beauty of it. So, all right, well done.